Hello and welcome, I'm your Code Monkey. In this lecture we're going to enable the player to pick up a kitchen object, and in doing so we're going to learn about another awesome C# feature called interfaces. Okay, so right now with our game I can already move the player, I can approach a counter, interact with it to spawn an object, and with the testing key I can move it to a different parent. So all of that logic is working, now let's make it work actually with the player. Let's say when we interact once we want to spawn it, and if there's an object already on top of it and I interact again, then I want to give it to the player. Okay, so here on the clear counter script, we've got our interact function. And in order to make that work, we need to have a reference to the player. So let's just pass it in over here as an argument for our interaction. So just pass in the player reference. Now over here, let's do the logic that I said. So if the kitchen object is null, so if there's nothing here, then let's spawn it. Okay, great. But if there is something, then let's give the object to the player. So how we change the object parent is just like what we did up here. So let's go into that one, set the clear counter, and pass in the player reference. Except, of course, this obviously does not work. The parameter on this function is supposed to be of clear counter. It does not work with the type of player. Basically, all the logic that we built for setting the parent and changing the parent, this whole thing only works with a counter, so it does not work with any other type, so we cannot set the player as a parent. Now, to solve this problem is exactly where C# interfaces come in. Again, I have a video going through them in detail. Definitely watch it to learn everything about interfaces. Basically what it is a contract. You define some functions in the interface, and then any type can implement that interface, and you can write some code that works with the interface, which in turn means that the code will work with any type as long as it implements that interface. So in this specific example, we're going to make an interface to represent a kitchen object parent. Then we're going to implement that interface on both the counter and the player, and that way both of them won't be able to be parents of a kitchen object. So let's do exactly that. Now the first thing we do to define an interface is let's make a C# script. So let's right click, create a new C# script. And now the standard is to start interface names with the capital I and then the name. So in this case, let's name it I kitchen object parent. And let's open it. Okay, so now to make an interface, first of all, this does not extend mono behavior. Nope. And secondly, this is not a class, instead this is an interface. Now, like I said, an interface is essentially a contract where each class that implements that interface must follow that contract. What that really means is that you can define a bunch of functions here. By the way, quick note, you can also define properties, but not fields. I cover all of that in the dedicated interface video. But for now, here we just want some functions. Like for example, let's just put all of the parent functions that we made previously on the counter. So over here on the clear counter, a while ago we made all of these functions that we needed to make it work as a kitchen object parent. So we got the transform, set kitchen object, get it, clear it, and has it. So let's just copy all of this and paste it over here on the interface. However, one important note is on the interfaces, you don't actually include any function implementation. The implementation is up to the class that implements this interface. Although again, I should also point out another quick note. As of C#7, you can include a default implementation, but that's for more advanced use cases. So for here, let's just use the basic and not apply any default implementation right here. So we just define the function and put a semicolon. So just like this, just the function definition with the exact signature. So just like this. Okay, so now with that, we have defined our interface and all of the functions that we wanted to have. With this, now let's go onto the counter script. So over here on the clear counter script, over here, let's implement the interface. And the way we do that is pretty much exactly the same as by extending a class. So over here, we are already extending mono behavior. Then let's set a comment, and let's say we are also implementing the iKitchen object parent interface. So right now you might be wondering, so is this pretty much the same thing as extending a base class? And kind of, except for one huge difference. When extending a base class, you can only have a single base class. Like for example, over here we have mono behavior. You cannot extend multiple base classes. There can only be one. However, when it comes to interfaces, you can implement as many interfaces as you want. So over here we have defined our interface, and right now we don't even have any errors. That's because we already implemented pretty much all of the exact functions. Also, Visual Studio has a really nice helpful icon over here on the left side. It is basically saying that this function, this implementation is based on the interface. But let's see what happens if I decide to comment out these functions. So if I comment out all of this, and if there we go, over here we have an error. It is telling us that this class does not implement the members for the interface. Like I said, an interface is like a contract, so you must write all of the functions included in the interface. so we must implement these. So let's get rid of the comments. Okay. With this, our interface is perfectly working over here on the clear counter. Now let's just go into the kitchen object over here on this script. For now, we're still working with the type clear counter. So let's just refactor this to, instead of working with a clear counter, let's make it work with a kitchen object parent. So let's just change this from type that to kitchen object parent. Let's also rename this. So let's use Ctrl+RR for the kitchen object parent. Then we got a function to return the kitchen object. Okay, that's good. For this one, instead of set clear counter, let's once again rename this to set kitchen object parent. And inside, again, we receive of type I kitchen object parent. Then let's also rename the parameter to kitchen object parent. Okay, so all the names here have changed. Okay, they're all correct. We set it, we assign it. Over here instead of counter, let's say kitchen object parent already has that. So just like this. And finally down here, let's return I kitchen object parent and rename this to get kitchen object parent. And we return that. Alright, so we have changed everything. I can even do Ctrl+F to search for a counter, and nope, there's no instance of any counter. So all of this code has now been rewritten to work with a kitchen object parent. So like this, everything should be working exactly the same as previously. We have no errors here. And over here on the clear counter, we just have this error on the player. Let's fix this in a little bit. For now, let's just comment it. Let's just test it out to see if everything still works exactly the same as previously. Also, one final thing, since we modified the interact function over here on the player class, when we have the interact, we just need to pass in this reference. Okay, so let's test. Alright, so here we are. Let's approach this one, interact. Yep, there it is. Now let me press the testing key, and yep, there you go, it does move. Okay, so everything is still working exactly the same as previously. Once again, another successful refactoring. Now here comes the magical moment. So right now, again, everything is still working exactly the same as previously, so we can only have counters as parents. But now let's go over here onto the player script. And over here, let's also implement the same interface. So let's implement the I kitchen object parent. And again, as usual, we have our error, so we need to implement this. Also again, Visual Studio is very helpful, so we can click on the light bulb icon and let's say implement the interface. And if we scroll down here, it will automatically create all of these functions. So let's just actually implement them. So for implementing this interface, the code is really going to be exactly the same. So let's go up here into the clear counter. Let's go down, find all of these functions. Let's copy them, and on the player, let's paste them down here at the bottom. So we just need to also pick up the kitchen object as well as a reference to the top point. So over here on the clear counter, let's just grab both those. So let's just grab the kitchen object. So go into the player, and over here, let's add a field for the kitchen object. And finally, let's add another one for the counter top point. So over here, a serialized field for the counter top point. Except obviously the player is not a counter, so this name makes no sense on the player. So let's just quickly rename this and call it kitchen object hold point. Okay, here we have our new name. We've got the kitchen object, and down here, all of our functions, they're all working, no errors. All right, now let's just assign this in the editor. So over here, let's just go into our player. There's the player script and requires a reference to the kitchen object hold point. So for that, let's do it just like we did for the counterpoint. So inside the player, let's create an empty game object. Call it the kitchen object hold point. And now basically let's just position it just slightly in front of the player. So let's put it on a x of 0, on a y of 1.3, and on a z of 1. So there you go, just ahead, that's where the player is going to be holding the objects. Finally, over here on the player, let's just drag that reference. Okay, so far so good. Also one note here, like I mentioned previously, in order to implement the interface, it requires you to write the function code. Basically what this means is that different objects can implement the exact same interface whilst having different implementations. So for example, over here on the player, when setting the kitchen object, perhaps over here you could play some kind of item grab animation, or maybe when clearing a kitchen object you could do some kind of logging. The only thing that needs to match perfectly is just the function signature. And the function signature, that means the return type, as well as the name and any parameters. The implementation itself, that is up to the class that wants to implement that interface. But in this case, we want it to behave pretty much exactly the same way, so like this it should be working. So we can now go back here onto the clear counter script, and okay, we have our interaction, alright, great. So if there's nothing, we're going to spawn it, and if there is something on top of it, we want to give it to the player. So now let's go into the kitchen object, and call the function setKitchenObjectParent and pass in the player reference. And that's it, no errors. Because again, this takes a parameter of type kitchenObjectParent and the player does implement that interface, so that's all valid. Now with this, let's test and see if our code is working. Alright, so here we are, and let's interact with this counter, and there you go, the object has been spawned. And now if I interact again, yep, there you go, look at that, the player picked up the object. And since our logic is using a transform hold point as the parent, the player is automatically carrying this tomato. Alright, awesome, so this is really great. Now over here on the counter, we no longer need all of this testing code. We now have the ability to actually pick up objects from the player. So let's get rid of all this so we don't need this testing code. Don't need a reference to the second player counter or the testing. Okay, great. So here you can see the power of interfaces. By just implementing the interface, we can now place an item anywhere we want, and importantly, on any type we want. So the counter can hold a kitchen object, the player can also hold it. We could make a dog character and make it hold a kitchen object. We could make a vehicle hold it or anything. Again, interfaces are really awesome, one of the best C# features. Definitely go ahead, pause this course for now and watch a dedicated video on them. You should be very familiar with interfaces. They will help you in making all kinds of systems and games. If you want to see a clear example of the power of interface, you can go watch my How to Interact with NPCs video. That video takes advantage of interface to make sure that the player can interact with any kind of object. Alright, so thanks to interface, we can now change the parent of the kitchen object and put it on either a counter or the player. Now in the next lecture, let's make a proper different counter type.